Hey guys, Tim for MVP Machine. This is the second installment in my fly cutter versus face mill series, and likely the last. But in the first video that we did a few months ago, we basically showed you a comparison between using the fly cutter, and specifically the Suburban Tool Fly Cutter with the 7.5-inch bar, and a Sumitomo 3-inch face mill of the shoulder mill variety. Difference between a shoulder mill style face mill and a regular face mill that just is designed to rip off stock at a rapid rate. You can sometimes use these to chamfer corners. Is that the shoulder mill can cut up against walls, thus the name shoulder mill. But I basically showed you the economics of using each of these tools to remove the mill scale from a piece of hot rolled plate. And just a brief summary is the fly cutter insert is approximately a $7 insert with 6 tips, and each tip approximately $1.10. And face mill has 5 inserts with 2 sides, and each side is approximately $7 a piece times 5. So my conclusion is the best tool for the job was the fly cutter. It's actually designed to take light cuts where it doesn't harm the insert, and the abrasiveness of hot rolled milled scale is quite high, and to use a cutter that's designed to take larger, deeper cuts, I should say, it's just not economical, and plus you don't get as nice of a finish or as flat of a finish. So that was our discussion in the last video. In the video today, I'm going to be pointing out when I say fly cutter versus face mill, the versus doesn't mean it's a competition. Really, you do need both of these tools, and they're both used for not entirely different things, but the face mill is used for taking larger amounts of stock and deeper cuts, and fly cutter is basically for fine finishing, but it has some other tricks. So we're going to do a comparison between what these two can do, and we'll see which one's the more versatile tool. But as I said, it's not really necessarily a competition because the two tools are designed to do two different things. So fly tool has roughly been around probably in certain variations since the early 1800s, late 1700s, for use in watch and clock making. Face mill is relatively new in this configuration with the indexable inserts. They originally started out in likely the 60s with brazed inserts on them, brazed carbide inserts, and probably before that with brazed high-speed steel. But these are both modern tools. This one roughly was created around 2007 or so, and this one around 2010. So modern tools with modern geometry, and they both work quite well for what they're intended to. So we're going to do a few demonstrations, and we'll go from there. Okay, we're over at the machine. I've got our 6-inch plate set up, and I've got the fly cutter set up to take a 15 thou cut. I wanted to briefly explain to you guys why the fly cutter is so much better and less insert wear occurs when you use the fly cutter to take off the mill scale. If you look at the insert for the fly cutter, it is a single point, and we're only using one insert on the fly cutter, or one tip, as opposed to using 5 at the same time of the insert for the face mill. And it has approximately an 1/8 inch flat on it, so there's much more surface area in contact with the part, and also the clearance on the fly cutter, since you're using a single point, you're basically not recutting chips, and On the Facemill, you've got 5 inserts, all at risk, all cutting and basically grinding those chips and recutting them because there's no way for the material to exit. You can use air blow, you could use coolant, but you shouldn't when you're doing this. That will cause more insert wear. But when you get a high positive chip breaker like the fly cutter has, it's actually a negative rake tool with a high positive chip breaker on the TNMG 432. It gets under the mill scale when you take a depth of about 14 or 15 thousandths. The mill scale is usually about 10 to 12 thousandths deep. So you're basically peeling that layer off instead of cutting it and the abrasiveness of the mill scale grinding on your insert. And we'll show you a slow motion view of the chips coming off this with a 15 thousandths cut. Now, as you can see, there was clearly a chip coming off, and basically every revolution we were running at 680 RPMs and 6 inches per minute. So it's peeling that material off rather than grinding it. And this is what the chips came off looking like. No heat is transferred to the part when you're cutting it. It basically goes into the chip, and we have a slight yellow color at this end and just starting to turn a little bit bluish at the opposite end. And that tells you that you're getting the heat off with the chip and you're not grinding up that mill scale that's on the surface. You're getting under it and just throwing it off. Now we'll show you, we'll flip this plate over, and another point I wanted to make about the fly cutter is, if you notice, I'm cutting in a direction normally you wouldn't cut with a mill in the vise. You'd want to go from the right to the left so that you're directing your pressure towards the back jaw. And it really isn't that important when using a fly cutter because you're putting such light surface pressure with a single point insert that you're not going to throw apart. That's why this tool is really good for flimsy parts and for weldments, because it exerts light tool pressure, and also good for like a Bridgeport mill where you're not using a lot of horsepower to take your cut. It will barely move my load meter when taking a cut like that, or even a much greater cut. In aluminum, you can take 1/8 of an inch with this tool, and you very rarely see the load meter go up on the spindle. Just that single point tool just exerts very little pressure on the part. So now we're going to set up the other side, and I'll try and get some slow motion footage to show you the difference between the chips that come off using 5 inserts on that Facemill. Okay, I've got the 3-inch Facemill set up in the spindle. We're going to be taking the same 15 thousandths of an inch cut, but this tool actually, to do it properly, it would require 3 passes because it's a 6-inch plate, and these inserts have a 32nd of an inch radius. So there's going to be a line left in the middle, but I'm going to just do 2 passes, and I'm going to show you in slow motion the chip that comes off the first pass, and we're going to look at the finish, and then we'll take a second pass. I normally would use air blast or air blow, however you want to refer to it, to remove the chips, but I won't on the first pass, so you can see what the chips look like in slow motion. And then on the second pass, just to see what the finish difference is, we'll put air blast on, and we'll see what the finish looks like, and we'll go from there. Okay, here's the finish from the first cut. I was running at 720 RPMs and 14 inches a minute, and it's not a terrible finish, but it's not great. We had a variety of chip sizes coming off of there, and that's due to recutting of the chips, and that's why you get the scratchiness on the finish. because it drags the chip partially and then cuts it and pushes it into the part. Now we'll see on this this second side if air blast will help evacuate the chips. And another thing, it sounds very scratchy when you're running the tool, and that is because of the straight side of a shoulder mill. It's cutting into that mill scale, and that's one of the reasons I don't like using these tools for this purpose, because it's so abrasive. And technically this tool is made to take a much deeper cut than that, and when you don't take that deep cut, the chips don't fly off it properly, and you're recutting them. Even if you're using air blow, it's going to happen. There's just too many flukes here. So anyways, we will take that cut and see what happens. Okay, we're ready to take this cut. I'm going to turn on air blast, and here we go. And as you can see, there's not much of a difference between the two different sides. The air really had no effect, and would coolant have helped? I highly doubt it would have done anything. And when you're using coolant on a Facemill like that, the thermal shock to the inserts causes even more wear than the mill scale would. Okay, I've got a sample part set up. I wanted to show you basically how I use the Facemill and fly cutter together on a lot of parts. This is going to be a rather large clevis. That block it's an aerospace material. It's 6 inches, or I'm sorry, 6.5 by 6.5 by about 10 inches tall, and it's going to become a big clevis. Basically, there's going to be a large slot that goes through this part, and I'm going to use the face mill or shoulder mill to cut that slot to rough it in, and then I'm going to show you how I use the fly cutter to finish it. And that material was a very interesting material. It's about a third of the weight of steel, but a lot stronger. It's used for making basically aerospace dies, very large dies. Think 80 feet long or so. And they basically make a positive and negative out of this material on a huge bridge mill, and they use it to stamp out aluminum fuselage parts. Very interesting material. It cuts real well. If this were steel, I would still be using the same tools to cut it, but this is an example because it's a part I have to make. And when I use this material, I've already squared it up on the machine, and when I use this material, I always put a liner so that, because I don't use coolant when I'm using this material, to catch all the chips from it. So I'm going to touch off this part. I always touch off face mills and fly cutters running over the top of the part rather than using a presetter. I'll just run the spindle and then jog down one thou at a time until I either see or hear the cutter make contact. And sometimes right there I heard it. Sometimes it's hard because materials like this cut fairly easy, but I'll show you real quick why I do that. I just wanted to show you guys with a mag base and an indicator set up under this 3-inch face mill. I've got one of the flutes zeroed out. Zero is right here, and I'm just going to spin that and pick up each flute, or each insert, I should say. We've got 2 of them that hit 0. The third one that's a couple thou shy. Fourth one's a couple thou shy. And the fifth one is a couple thou under. So reason for that, it could be dirt under the one side of the tool when it was mounted to the arbor, or it could be just the accuracy of the tool and the inserts. And the way they're in there, but usually on large tools like that, if you use a presetter, you're going to be just touching off one of the inserts or one of the flutes on it, and that won't give you an accurate depth of cut. And with the fly cutter, same thing, it's so large, if there's a piece of dirt, little piece of a chip under one side of the arbor, it's going to have a big effect on how that tool behaves. So that's why I always touch both of them off running, and you'd be surprised the difference you get between that and just touching it off on a presetter. Okay, I'm ready to go on this slot. A little bit more about that material. I cannot give you a name on it, but if you think of something similar to auto body filler, where it's a two-part type polymer, this is just a much higher quality, and it's extremely hard. You can take a sledgehammer to this stuff and it won't even put a dent in it, and that's why they use it for that dye material. So here we go. We're going to be going at 1400 RPMs, a 1/4 inch cut per pass, and we're going to be going, I'm going to try to get to about 35 inches per minute, but it'll take a pass or two before I'm comfortable with that. So I've got it turned down right now. And here we go. We're going 5.5 inches deep on this, so it's going to take a while. I'll show you a few cuts and then I'll fast forward to the end. And it looks like I've guessed about right on the feed and speed for this. I don't like to use air blow on this because of the dust. So we'll probably fast forward and to the end and we'll go from there. Okay, that slot is now roughed in, and that's going to be right around 3 inches right now. Well, there's a 1/4 inch on each wall, and I'm going to use the Facemill to get it within 10 thou per wall. And I still have to leave a radius down here. So this is actually a 1/4 inch deeper than it needs to be. And there's going to be a radius for strength at the bottom. So I am going to do that cut to get it a little bit closer to finish, and then I'll show you how we actually finish it with the fly cutter. Okay, I've got it set up to basically semi-finish those sides. It's going to go down 5 inches, so we'll have like a 1/4 inch step at the bottom. Then I'll be able to use a ball nose end mill to put that radius in at the bottom to give it extra strength. And here we go. I'm kind of careful. I'm using the extended 4 inches on my Z-axis, so I slow everything down until I'm sure it's going to get into the part right. And we're going 1500 RPMs and 45 inches a minute on this cut. Ramping down a 1/4 inch per pass. It looks like I can go much faster on the feed rate anyway. Okay, now we've got our little step in there that I can use the ball nose to put that radius in. So I'll do that real quick and then we'll show you the last operation. Okay, I've got a rather long 6-inch bull nose end mill in there with an 1/8 inch radius. I'm going to take out that last little bit in there. I'm going kind of slow. Okay, now that radius is in the part. And we've got a few thousandths on each wall. And I'll set it up on the last operation for the fly cutter to finish that slot. Okay, I was hoping to do this part in the vise, but I didn't have enough clearance. And I was also hoping to use the 7.5 inch bar on the fly cutter. But as you can see, I have the 11 inch bar set up. I was missing by about 3/4 of an inch on enough length to get in here. But what I'm going to do is I am going to cut the bottom part of this first. Then I'm going to flip the bar upside down and cut the top of this, and that'll give me perfect flatness. It works excellent for these clevises. If you were to try and finish that with an end mill, especially if this is steel of any kind, your deflection on the end mill will cause all kinds of accuracy problems. And even on this material, as easy as it cuts, you have chatter and accuracy problems. So I'm going to show you how I set up the fly cutter to manually cut this. If I was doing a bunch of these, I would make a program, but since I'm only doing one, I'm just going to manually set it up and run it across each surface to get the numbers that I want. So let me show you how I set this up. Okay, I've jogged the fly cutter into position, and what I'm doing is basically just trying to find the back surface here with the fly cutter. So you can rotate the bar when you hit. You want to back off. And I do it 1/1000th at a time until I just clear that. And then I need to clear this radius because I'm going to be cutting this surface. So I'll back out an additional 1/8 of an inch. And then I'll come down here and I've got to touch off on this. So let me show you that. Okay, I've moved the fly cutter down pretty close to touching the surface. I've blackened the corner of this part with a Sharpie marker. And basically I'm just going to jog down until I get a witness mark there. And 1 thou at a time. And when I get my witness mark, I'll go back up 1 thou. And that'll give me my number. So I've got the, I'm going to run the spindle. Yeah, you have all kinds of clearance issues you got to be careful about when you're running this big tool. So I always manually swing it around, make sure I'm not going to hit anything. So here we go. And I can hear it hitting. And there I see the witness mark. I'm going to go back up that one thou. And that's how I established that number. Okay, now that I have my numbers established, I've moved off to the side and I'm getting ready to take this cut. Taking a 6/1000 of an inch cut, and then we will do the top, and we should have our number that we're looking for. So here we go. I'm going at 600 RPMs and about 5 inches a minute. Okay, here goes that second cut. Now I've left the the outsides of this. They're basically it's squared, but I'm going to cut everything to the slot. So as long as the slot is correct, I'm going to work everything off of there. Which might not always be the way you'd want to do this, but in certain kind of steels, I definitely wouldn't want to make this part out of cold rolled. You'd have to flip-flop it all over the place and leave stock everywhere. Would be a nightmare. Okay. And that's what our slot looks like finished on the bottom. And it looks like we're pretty good in here. Nice and flat, nice and smooth. And we're going to set up some Joe blocks real quick to check where we're at all around, and then I'll know how much I need to take off of the top. So let me get that set up. Okay, I have the bar set up upside down. I have it touched off the same method off of the bottom of the slot, and I use the same method to touch it off on the top wall of the slot. And we're going to take that cut. When you use this cutter upside down, you have to run the spindle in reverse. So running at 600 RPMs, and it is going counterclockwise. I'm taking 5/1000 of an inch. I determined that I need to take another 10, so I'm going to do 2 cuts at 5. I'm going to check in between. I'm going to check that real quick. I'll adjust it and take the last cut, or hopefully the last cut. Okay, the Joe Blocks told me I have got 5 more to go. I've got it set up. I'm going to take that last cut. Okay, we should be at our finished number. Let me move the tool out of the way. I'll get a better view of this and we'll check it with some Joe Blocks. I'm fairly confident we're right. We're shooting for 3.5 inches, and here's the Joe Blocks, 3.5 inch. Let's see what we get. And there we go. Let me make sure it goes all the way back, which it does. And that's a way to get a perfect slot. Usually when you move that cutter a couple of thou each way, it doesn't really have a problem taking those light cuts. So now what has to happen to this part is the outside has to be profiled. The hole has to go in through that slot and some cutouts on the back, but I think I'm going to wrap it up at this. And basically, it's a good example of how I use Facemill and fly cutter together. Like I said at the beginning of the video, it wasn't really a competition comparing them. But if you enjoyed this video, please like and please be sure to subscribe and hit the notification bell.